Hi everyone, welcome back to the channel. So the problem that we are trying to solve over here is 3643 flip square submatrix vertically. So the problem is very simple. Let's understand it in the grid over here. So we are given this grid and we are also given x that is 1, y that is 0 and k that is 3. Now x is what? X is the row. So over here this is x0, x1, x2 and x3, and this is y0, y1, y2 and y3. And now we have to find out like the k3. So what is this k signifier? This is the length of the square that we need to swap. So when we identify, so 0 1 2 3, so this is what we need to work upon. This is the sub square matrix that we need to work upon. So first we identify the playground, and this 3x3 matrix is our playground. We have to play in this area itself. Now the problem that is given to us is we need to swap. Now let's see it in the other grid, which is the same one. We need to swap, and what do we need to swap? We need to swap rows. So we need to swap this row with this. As there is only 3, this one will be swapped by itself, so it remains the same. Now what will happen when we swap? So this 5 will be replaced by 13, and similarly 13 will be replaced by 5. 6 will be replaced by 14, and 14 will be replaced by 6, and 7 will be replaced by 15, and 15 will be replaced by 7. Now if you'll see, this is the matrix that we need to output. So I hope the problem is really clear. Now let's jump into the constraints. So if you follow over here, constraints are nothing but 50. So if like even if we do 50 square, that is n square problem, it's much less than 10 to the power 8. So the constraints are very low, so we don't have to worry upon that. Now let's understand the intuition behind it. So what intuition I get? So we are given the grid, we are given the starting coordinates as well, and the k. So using the k, we can define our ending coordinates. Can we do so? What will be the ending coordinates over here? Let's see. So our x is 0 and x is 1, right? Our x is 1 and y is 0. Now if we see, we have to swap it. Now what will be the coordinate that we need to swap it with? So 0 1 2 3, x should be 3, and y will be the same, 0. Am I correct? So we got to know that y's are gonna be the same j. So like it's gonna be the same for the swap one. Only thing that is changing is x. Got it? Now how do we define it? So what is x? Now we have to derive this x equal to 3. Suppose it is, we are given k is 3. So we are saying x plus k, what does it become? It becomes 1 plus 3, 4, right? Now we have to subtract with the current index. So we are looping going down, right? So if we are subtracting by I, that is our current row, minus of x. So do you understand what I am doing? So x is 1, that is our starting point. This is our starting, this is the maximum that we can go. So we have identified the last point. Got it? Now we have to subtract, and we have to also do minus 1. So what will happen is, this x plus k minus, now currently our I is x itself, so it becomes 0, then minus 1, so it turns out to be 3. Am I correct? So this is our equation that we have found out. Got it. Now let's jump into the problem. Yes. So if we loop through, what are the loops that we are gonna see? It's the exact same problem. The hard part was just to find out the equation. Now we loop till x k to the power k by 2. Oh, why k by 2, right? Okay, let's see in the grid itself. Now if we see in this grid, if it was 4, it was all rows that we need to swap, then what will happen? We'll swap with this, we'll swap with this, then again we'll swap with this. So because our I is jumping right, so we are jumping the I only till middle. You got my point? So we only see the swap over here and swap over here. We do not repeat the swaps, which is great. So we are looping till x k by 2, then we are looping j till y plus k. There is no condition over here because j's are gonna be the same and we have to loop to all the elements. Then we swap and it's the exact same condition. I, j is swapped with x plus k minus I minus x minus 1, and j remains the same that we saw, and we return the grid. Let's see it in code. So over here we first define our I, that is equals to x. So and then we start the loop that says while I is less than x plus k by 2. Got it? Now we have to initialize our j, that is looping through our y's, that is columns. Then we loop and this becomes y plus less than k. Now we have to swap, and what do we have to swap? I comma j is swapped with, I should like this because it's swapped with x plus k minus I minus x minus 1, and the j remains the same. I hope you have understood why we are doing I minus x. So this is our starting point. This is the maximum that we can go. We are looping from the back now. So and this is the position that we are currently at. So it is giving the position encoding. Now just the normal swapping method, we can create a function as well and do it. Currently I'm doing over here itself, grid I j, and then grid I j is actually replaced with grid of the same x plus k minus of I minus x minus 1, and j remains the same. Now grid of x plus k minus I minus x minus 1, j is again swapped with temp. Now we do j plus 1 so that our loops keeps on continuing, and I plus 1, and we return the grid over here. Let's see and try and run it. Okay, superb. All the test cases are passed over here. Now let's submit the problem and see. Awesome. So we are seeing that it has passed. This was a simple problem. I hope you've understood it. See you in the next problem. Thank you so much.